essentially an ability to compute what is the actual cost on the ground at a Kubernetes object level, like a namespace or a deployment or a replica set or a persistent volume claim, and then having the ability to reconcile that with the actual cloud construct is the real key.
So Abdullah, thanks a lot for joining us. So today for our audience, we'll talk about a CTO's outlook on striking a balance between cloud cost and business KPIs. So Abdullah, thanks a lot for joining us.
Thanks for having me.
Okay, Abdullah. Let's get started. So how does today cloud cost landscape look like?
So essentially, when we talk about the cloud cost, right? So it essentially means the just the definition, right? So the cost that you have to pay when you run your applications that are deployed on the cloud. And when you talk about applications, no two applications are same. Maybe it's just a website that's just serving some static content, or it's a sort of a streaming solution that involves a bunch of different services talking together. And each of these have different requirements in terms of compute, storage, and networking, and all of these things incur cost. And they have different cost models across different cloud providers. So essentially, the cloud cost landscape means that depending on the cloud that you are deploying your application on and the context that your application is operating in, it will all contribute to the eventual cost that you will have to pay once all of your things are actually done.
Okay, Abdullah. So why should DevOps care about cloud cost? Any challenges monitoring cloud cost?
Right. So when we talk about DevOps, like, what does that essentially mean? That's developer operations. Essentially, when you deploy your applications or you develop your applications, the operations that are required to run it smoothly. And with all this modern tooling and technologies, IAC and dynamic environments, this provision of the infrastructure for your application has really become an agile process and a dynamic process. And this is sort of worsened by the fact that there are multiple environments that your code runs in. There is dev environments, test environments, staging environments. And if you don't pay attention to what you're actually building as part of your DevOps pipelines, your costs can quickly balloon up and they can just go skyrocket, right? There are things that people do to actually embed the steps that you need to take to control your costs. It's also sometimes referred to as FinOps, as in operations for your financials. It involves long-term solutions, for example, forecasting, and medium to short-term, like budgeting, monitoring, and having insights into the environment that you're actually running in. So all of these operations relating to what essentially contributes to your cost insights, monitoring, and reduction, they're collectively also known as FinOps. But from a DevOps point of view, we have to create a culture where essentially this is embedded into the part of the building solution itself.
So Abdullah, what challenges do people face in monitoring cloud cost?
Right. So I think I touched a bit upon this in the answer that I gave, but essentially a lot of different environments where your applications run on with dev, stage, and test. And at the same time, when you're developing, a lot of time you over provision resources that sometimes can lead to a lot of unused resources as well in your environment. And those are some of the challenges where there is sometimes this frictions between developer and the operations team as well, where developer just quickly wants to build something up and they don't want to care about the cost. But at the end of the day, for business viability and continuity, you have to look at what is the footprint for your applications that are running. So if it becomes an afterthought, then it becomes increasingly difficult to trim off your sort of costs that you have incurred. So if you design it the right way to start off with, where you model the costs when you are deploying your applications, that way it becomes a relatively smoother process to embed that mindset that you have to build solutions that are cost efficient and effective when they're actually deployed.
So Abdullah, how can you predict your cost footprints once you deploy your app? So there are different cloud providers and they have different cost models. Okay, how do you choose one?
Right. So essentially, all these cloud providers provide you a way to model your applications and predict the costs that you are going to incur once they are deployed. So AWS has a price calculator, GCP has a price calculator, but they will just give you sort of an overview of you pick and choose services. Okay, this is what my outlook of my application looks like in terms of the number of services, their interactions, network, compute, and storage, and this is what the cost will look like at the end of the month. Right? So that's how you get an insight into this is what my outlook would look like. And but again, that depends a lot on the context that the application is operating on. Maybe if it's a streaming application and one cloud provider's storage cost is less than the compute cost of the other cloud provider, then it essentially means that you have to understand the context of where your application is operating and then take it from there. But you do have a way of modeling your cost with all of these different tools.
So Abdullah, how do you model cloud cost usage and build KPIs around running your application? And how do cost KPIs map to business goals?
So you can, we talked about it a bit before, that you can use different cloud providers tools to predict that what is the calculator tools to predict what the outlook of your application would look like. But that will just give you sort of prediction of sort of once it's deployed, what it does look like. You'd really need to have a reconciliation strategy as well to actually observe once your application is running, what is the cost that is it's incurring. And what that really means is that you have to have an observability strategy to see what is your application, what context it is operating in right now, what is the amount of, for example, network bytes it is actually sending through peak time, what is the cost that it is incurring at that time, and then those become your sort of KPIs that, okay, maybe I was expecting X amount of bytes to go out, but it is Y amounts of byte. Do I need to define a threshold that alerts me that, okay, my cost is going to balloon up because of this peak traffic? And if that happens, then what is the workflow that you essentially implement to do that? Is it just an alarm? Is it a notification? Is it something that you want to trigger a workflow that, okay, I do not want to incur costs at all costs, just shut down everything? And then these thresholds and KPIs can map to your business goals. That, okay, I have a strict budget constraint and I know that I cannot go above Y amount. And if I have modeled my observability strategy and cost in a way where I can define these individual thresholds, you can map them to direct revenue and sort of budget constraints and take actions that can ultimately help you keep in the constraint that you have.
So can you name some of those KPIs that are frequently used?
Right. So some of the KPIs in terms of the cost is, of course, right, what is the network bandwidth that is currently being used. Right? That's one key performance indicator in terms of the network usage. Similarly, storage and compute as well. So these three major things are what incur costs. So your KPIs are essentially built around these. So these are the thresholds that you can see in terms of each of these network, compute, and storage, that if I go beyond a threshold in any of these categories, what do I need to do? And that is where your reconciliation between the actual business KPIs comes in as well.
And then once you said that you need to build an app with observability in that, so what strategies do you use to actually have that kind of observability in the app?
Well, so there are different tools that allow you to actually get insights into those. Primarily, it's so cloud providers give you different tools themselves as well. For example, AWS has built-in integration with CloudWatch, and it has built-in integration with alarms. It allows you to create alarms on the bill that you are incurring. So those are some of the things that you have to build in, but that's just at a higher level. That, okay, if my application or all of the resources that my application is using, it crosses X amount of dollars, notify me. But it's a lot more than that. So you have to actually have observability built at a lower level than this in terms of during peak times, what is my application behavior and what are some of the resources that contribute to that threshold being breached during that peak time. That's where that fine-grained observability comes in and helps you identify that, oh, this is the peak time where the cost ballooned up, inside of my application, this is what was happening. This is what was contributing to most cost. Maybe your application has a lot of microservices talking to each other in an unoptimized way during peak hours that might contribute to a lot of traffic going east-west between the application, and it can just quickly incur cost. Maybe you do not expect that to happen. So if you build the right observability strategy and you know that you can pinpoint some revenue or cost spike to a particular event that is happening in your application, you can have remedies and built around those.
Okay, so are there any inherent ways of building application like a monolith versus microservices-based architecture better in terms of cost?
I wouldn't say it's more like a monoservices or monolith or a microservices based question. It's more like whatever the resources your application uses, you need to have observability and insights into if something is peaking up, what part of my application is using the most resources, right? And if those resources are the ones that are contributing to your cost. That's more towards it. It's not more about the architecture of the application.
So what are the cost implications for over-provisioned or unused cloud resources? Will cutting costs affect my application performance?
Right. So a lot of the time what happens is when developers are actually developing applications, they really do not care about whether they're over provisioning resources or if they're provisioning resources in multiple environments. All they want to do is develop applications at a rapid scale. And what that usually leads to is a lot of resource wastage and ballooning up in the costs, because we talk to our customers and we hear stories about that our dev test environments are actually costing us like orders of magnitude more than our production, is because someone launched like 10 Kubernetes clusters and never cleaned them up. And that sort of resource just leads to complete wastage, right? And once you get into that mindset of having different environments with different resources, then you ultimately have to decide whether all of those resources are required for your application's proper functionality. That's where the notion comes in that, my application is working with all of these resources. If I cut some of these resources, will it affect the performance of my application? And that's the point where you say that if you model your application correctly in terms of that, what is the compute, storage, or network requirements for my application, you don't have to go into that guessing game of my performance is going to be affected. But generally, there are different ways to tackle that. Some just use like sort of a hammer approach and shut off a bunch of resources and see what do we see, right? And based on that, then they build on top of that, bringing back resources slowly. But that is not really a good way of doing that. The right way would be to model your application and pinpoint what are the resources that it is actually going to use, and then just provision those, of course, with the notion of high availability and horizontal scalability in mind, but just not provisioning multiple resources that you just don't need.
Okay, so in terms of this over provisioning and unused resources, how do I get the visibility? If that is the case, if 30% or 40% of my resources are being utilized or not, how do I sort of like see all of this?
Right. So this is again. So there are lots of insights that you get from observabilities, right? And to model your application, so this goes on a lot more than just cost saving. This is essentially your application's behavior in terms of the compute, storage, and network requirements. Right? So if your application is fine, that okay, maybe I just need 5% of the CPU, 10 minutes at a time in 1 hour. You really don't need to provision a really high bandwidth CPU instance for that, right? So these are the sort of modeling that you really have to do to get those insights that, okay, whether my application is over provisioned in terms of resources or whether it's just fine.
So Abdullah, Kubernetes domain is actually coming up, and how do you sort of define the difference between cost optimizing strategies for cloud versus Kubernetes? And what are some of the additional things you need to consider for Kubernetes cloud environments?
Right. So Kubernetes, you're right. It's rapidly environment that is being rapidly adopted for applications, and a lot of organizations are migrating their workloads to Kubernetes. And Kubernetes has a lot of moving parts, right? So it's essentially a distributed system that has a lot of resources that it needs on its own to work out, right? And when it comes to Kubernetes, it's not just as straightforward saying that, okay, what are your node costs? That are your node costs the only things? Are your storage costs the only things? Because there are two levels of costs. One is at a higher level. So for example, when you deploy Kubernetes, you deploy a layer of network storage and compute on its own, right? So a Kubernetes node is going to run on an instance, right? So that's your compute. But once your Kubernetes workloads, there are actually fine-grained pods that run within that larger instance. So there would be a lot of different pods with different CPU requirements that actually use up the CPU that is actually provisioned for that instance. So a lot of the time what happens is what we see is people have huge instances that are provisioned, and their Kubernetes workloads take only a fraction of the CPU resources that they actually require. But they do not get insights into those by default, because their purview is at a node level that, okay, we have provisioned this CPU, this is what it's going to cost us. But it's essential that you model your application in terms of Kubernetes constructs. So there are tools like OpenCost that essentially give you insights into your Kubernetes objects and what are the cost implications of each object, reconciling it with the actual cloud usage reports, and you get insights into, okay, during my deployment, what was the cost that was associated to this unit of application within this larger unit of, let's say, instance of the CPUs, right? And that's what really tells you that maybe I'm deploying my application with 10 pods and it uses 20% of the CPU. The rest of the 80% is never used. Right? So maybe you can reduce your instance size to just be 20% of the overall capacity that you actually needed. So essentially you have to go one level down from just at cloud cost level to get insights into the Kubernetes ecosystems.
Okay, so how would you compare cloud cost of Kubernetes versus a serverless architecture?
Right. So in terms of the serverless architecture, that's definitely something that is different than this Kubernetes. Right? So Kubernetes is a sort of a distributed operating system where you deploy your workloads and they use different resources in terms of Kubernetes objects. When you talk about serverless, the cloud providers take care of the underlying server. So you just pay as you go for the code that is actually executed. So the cost model, I don't think there is sort of an apples to apple comparison here. When you're running things on a Kubernetes environment, there is a lot of things that you have to take care of yourself, because you are controlling how your pods are actually scheduled. You're still controlling the same thing on the serverless side, but Kubernetes is not pay as you go. That is, you provision the instances, and whatever cost that is associated with that, for that, let's say for CPU, you will incur that. The problems will come when your workloads are actually underutilizing those things. In terms of the serverless pay as you go, you just pay for whatever your application is doing, but that can still quickly balloon up if you do not model it correctly and your applications just deploy a lot of serverless instances instead, where they can just do something with minimal amount of those instances.
So is there a case where cloud providers will give discounts on already bought provision services versus as you go? Maybe the cost structure is sort of like done in a way that the variable cost is higher.
Right. So the different cloud providers have different concepts of these. For example, Amazon has reserved instances that you can reserve, and similarly spot instances. These will have different variants in terms of cost depending on your workloads, right? So spot instances are suitable for workloads that you think, okay, even if it goes away, I will just be able to rerun it, maybe for batch jobs, some things that you, for real-time applications, something maybe you just want reserved instances. These will have different cost models, and different cloud providers have different sort of discounts and things that they give to their customers depending on what are some of the actual resources that they're going to use.
So Abdullah, let's go deeper. So tell us about the tools and best practices for implementing this cost optimization for the cloud.
Right. So there are some tools out there that actually help you get insights into what your cost looks like and what are some of the things that you can do to reduce those costs. For example, NOps is a tool that helps you get the inventory of what your resources look like, what is the cost, and what are some of the things that you can do. One of the things that we really like here at Xgrid is Cloud Custodian. The beauty of that is it's a stateless rule engine and it works across different clouds. What it allows you to do is define essentially a group of rules and state machines that when those state machines change their state, they can do some actions. For example, you could say that I have a bunch of instances with XYZ tags. Every Friday, just shut them off and then bring them back up at start of the next weekday. What that will do is that it will automatically reduce your costs for the weekends, and that's the sort of the idea of that stateless rule engine. And that's just one example. You can create a lot more other rules depending on your requirements and take appropriate actions to do those. Maybe you just want to shut off some instances completely after doing some batch jobs, or maybe you want to deprovision something and reprovision something depending on your cost architecture. But Cloud Custodian definitely allows you to define that stateless rule engine.
Okay, so let's just talk about Kubernetes now. So what are some of the tools and best practices to implement cost optimization there?
Right. So Kubernetes being relatively new, it does not have a very evolved ecosystem of how do you actually get insights into costs and what are some of the things that you can actually do. More recently, there are tools that are coming out. One of the things that we really love and we help our customers implement those in their environments is OpenCost. So it's a tool that is essentially open sourced by a company called KubeCost, and what that does is that it allows you to get insights at Kubernetes object level of what are the costs of those objects, and then they reconcile that with the actual spending bills that you have on the cloud. So you get insights into this during out of my this deployment in Kubernetes, this particular namespace and this pod is contributing to the most cost in my overall bill. And other than that, they also have the ability to do compute out of cluster costs. For example, your Kubernetes applications, maybe they are talking to something out of the cluster. Maybe they have a managed database that they talk to. So they have a way to reconcile those costs as well. That overall your Kubernetes environment with a combination of its object level costs and the cost that it incurs when it talks to things like these managed services, what is the overall footprint of your cloud cost that looks like, that covers both the Kubernetes as well as any other managed services that you might be using.
So Abdullah, you're a Kubernetes expert, okay? So tell me some of the components or some of the tools that you would like to have in this domain of cost optimization for Kubernetes.
Right. So I think a lot of the things that OpenCost is doing are in the right direction, and we really admire that. Essentially, an ability to compute what is the actual cost on the ground at a Kubernetes object level, like a namespace or a deployment or a replica set or a persistent volume claim, and then having the ability to reconcile that with the actual cloud construct is the real key. And at the same time, what we really like is that it just not only works with cloud environments, it also works with on-prem environments. That you have a Kubernetes infrastructure on-prem, there is a way to model the cost of your on-prem infrastructure and feed that into OpenCost. Then it allows you to reconcile your Kubernetes object level costs to the costs that you have provided it yourself. That, okay, my current cost for this on-prem infrastructure server for the month is this. Now help me reconcile at a Kubernetes object level what is contributing the most in terms of this pod for this deployment, right? Overall, that's the general idea. And one of the additional things that we really think that can happen is getting insights and actionable recommendations of what you really need to do when you have identified. So putting observability, we consider observability as the precursor and prerequisite for everything that we do in terms of cost, security, or reliability. So once you have the right observability strategy to get insights, then what next thing that you really need to do, or really is the logical next step, is what to do when some event has happened. So let's assume that you have figured out that, okay, I have deployed an application in Kubernetes environment, and the pod in XYZ namespace is the one that is causing the most amount of cost, right? Are there any recommendations out of it? I would love to see that. Okay, yes, this is the cloud. This is the pod that is costing you the most, and it is actually over provisioned. It does not need that much amount of CPU. If somehow we can reconcile those sort of application usage behavior with the cost model, then it becomes like a one-stop shop for everything. That, okay, I have these things that are the most expensive, and they don't need to be. But that answer that they don't need to be is something that is really not out there today, and something that we really hope that we can build as well.
So Abdullah, I'm a startup founder. I'm building an MVP. Where should I start this cost optimization process? And is this the same for an SMB?
Right. So we really have to understand, what does an MVP mean in your journey, right? So if you are an early stage company and you have a tight budget constraint, then the viability of your product, essentially minimum viable product, has to include the cost constraints in there. That means you have to have the observability strategy built in that essentially allows you to build that product within those constraints, right? For an SMB, at Xgrid, we fundamentally believe that if you build your observability strategy in the right way and you have actionable insights into your cost modeling, then it becomes a matter of what stage of your life cycle that you are in, right? SMBs are generally at an advanced stage than MVP with tighter budget constraints. But as we said, if you have the right observability strategy, it's a matter of turning some knobs and getting insights and alerts and getting remediating workflows in place going on.
So Abdullah, there's so many tools out there. How do I adopt an organization to find the best and use those?
So, right. So this is a question that I really like. So there is one thing to have an observability strategy to collect data, have actionable insights, and then it is a completely other thing to actually embed that in your organization, where people or the services or the people that using those tools, they do not find those tools as a hindrance to their development process. So essentially, you have to work towards removing organizational friction that comes in with the introduction of every new tool. For example, a developer or even a DevOps team or even a FinOps team, for that matter, if we say that, okay, you have to use these tools to implement your cost control or observability strategies, it becomes a challenge to, from a human element, to talk about those things, that what are the workflows that are painless and frictionless that would not contribute to adding more stress or more workload to those folks. And at the same time, you have to control your costs as well. So the best way, in my experience, is essentially working with customers and working with Fortune 500s, is that you have to really set this culture and get the required mentality infused that this is something that is really important. That means the right amount of adequate trainings, the right amount of workflows, the right amount of benefits that you actually get through these cost savings, and what are some of the implications that if you do not do these things that can come in. So building mechanisms and observation strategies is one thing. The adoption of those mechanisms and the workflows to actually get the results that you really want, which in this case is cost reduction, is something that requires deeper thought, deeper collaboration among teams to reduce that friction and ultimately implement that strategy.